All right. We are going to get started here soon with the CCNA live virtual training. I got my Zoom students in the call. We're going to get started here in like 7 minutes. Soon. All right, sweet. Let's go ahead and get these slides pulled up while we're waiting. So usually day one, we just go over just the fundamentals, right? Just the easy stuff. Let me show, there we go. We usually show just the easy stuff here. So we're gonna be going over like the basics, like what a router is, what a switch is, layer 1, 2, 3, 4, and then 5, 6, 7, just like touch on the OSI model. Go over control plane, data plane, how a router switch boots up. We'll talk a little SDN, just a little sprinkle of SDN. We'll talk a little bit of wireless, a little bit of Wi-Fi. And then we gotta go over IPv4, IPv6, and then I usually send the students off to learn subnetting on their own. Since this is a paid course though, this live session will probably only be like 2 to 3 hours. I'll probably end it like after we go over the TCP three-way handshake, and then make sure the students feel like they got their money's worth, right? So let me go ahead and bring my chat up. Hold on, let me bring my chat up in OBS. One sec. Let's see. Okay. When will the training start? Yeah, we're gonna start here soon. One sec. All right, guys, let's go ahead and get started. So first, we're just going to talk about, does CCNA and Cisco certification in general. So we're going to go over the different types of Cisco certification, the different tracks, and what we're here to learn today when we go over the CCNA and what kind of cert, what is it? Why are we here? So here is the current this current Cisco certification track. So as you can see here, we have entry, associate, professional, and expert, the CCIE level. We're at the associate level here in the CCNA exam. So with CCNA, there's kind of this understanding that you're not a brand new beginner. Now, obviously, you go online, you search on Reddit, you look at forums, people will say you can start at the CCNA. And for the most part, that's true. Like, this does go over fundamentals like we're about to do today, but Cisco themselves pretty much is saying, hey, this is not entry. We have entry-level certs over here, the CCST, networking, cybersecurity. However, it's just kind of always been that way where the CCNA is kind of like the intro into networking, right? For a lot of people, besides like Network Plus, but when we're talking like a vendor-specific cert. So we're here at the CCNA, and the CCNA doesn't have a specific technology track like CCNPs do, where there's concentrations. This kind of just all-encompassing for like what a network administrator needs to know. That's how I look at it. It's associate level, so what does a junior or mid-level, even like a little bit to that senior level network admin need to know, network admin. So we learned layer 2 switching technologies, layer 3 routing technologies. We learned a little bit about layer 4. We learned a little bit about wireless, security, cloud, automation, and controller-based networking. It's just a little bit here and there just to make us a little dangerous on the network, have that understanding of a lot of technologies, but nothing too in depth for like enterprise level networking. Now we move on to the professional exams. That's where we start getting concentrated. I won't spend too much time on this, but like the CCNP Enterprise is for those enterprise network engineers. That's how I always saw it. And there's different concentrations in a lot of these different CCNP level exams. Like for example, you could get the CCNP Enterprise exam by taking a core exam. You need that core, and then a concentration. You could do advanced routing. You can do SD-WAN or a design concentration. I forget what it's actually called. And that'll get you the CCNP Enterprise cert. And then of course we have all these professional level and below, all exams that have multiple choice, obviously a few labs, and they're taken at a Pearson VUE Test Center. Now the CCIE here, this is gonna be something that's unique, that is completely lab-based, taken at a Cisco authorized facility, like at their headquarters or something. It costs a lot of money. It's an 8-hour lab exam. I know nothing about it because I've never tried it personally myself, but it is like the cream of the crop. You're the top 5%, if you take certifications that way, of network engineers or this technology that you're going for, okay? Now, before we move on, the CCNA exam, once passed, is valid for 3 years, and there's 2 ways to renew. One, you take a Cisco certification exam of equal level or higher, and that'll renew it for another 5 years. Or you do Cisco CEUs. These are specific to Cisco. You go on Cisco's website, like their Cisco University, there's specific CEUs that you need, okay? It's not like CompTIA where you can go to some boot camp somewhere, you get a 50-hour certificate, you upload that, and that's good to go. No, it's Cisco CEU specific on Cisco's website, okay? So even coming to my training, if I give you a certificate that says, hey, you did 40 hours of Cisco training with me, that doesn't count as CEUs, okay? It's not like CompTIA in that way. I'm a CompTIA trainer, so I always compare a lot, right? When it comes to just the certification track. Okay, little slide here just for fun, right? What does this certification do for you? So what can it do? If you're getting your first job in IT, now again, it's kind of weird how you look at it. I always see like a complete beginner in IT starting off the help desk, service desk, whatever that looks like, and then making their way into one of those concentrations, making their way into system admin, cloud, platform, DevOps, networking, cyber, right? Kind of starting at that help desk, analyst, service desk position, and then branching out to one of these concentrations. But there are some people, their first job in IT is networking. Like I'm from the Army background. My first job in IT technically was help desk, but then outside the military, my first job was networking. I was a network engineer right away because that's kind of just what the job I got, right? And I started doing networking right away. So sometimes this can be your first job in IT is just straight networking. There's a lot of cases like that. A lot of the influencers I follow that are into networking say that was their first job. They went straight into being a junior network admin, got their CCNA, and landed that junior network admin role. Now, a lot of stars have to line up for that to happen with zero experience, but I think it's possible. Making a change in your IT career, like I said, if you're at the service desk, help desk for a while, you want to get to that network shop, into the NOC, it interests you, you get the CCNA to prove to either your company or to another company that you're ready to be that network admin. Sometimes it helps with a college degree. So sometimes colleges, if you're in a CS program or some sort of technology program, they'll take certs in lieu of like college credits, maybe for a college class sometimes. It could be for career improvement. There's a lot of time companies like MSPs, big other companies that their value in certs isn't that high. They'll hire you based off what you know and your experience. You don't need a cert to go along with you. But when you get the CCNA, that could be, salary negotiation and leverage. Saying, hey, I got the CCNA. I want that network engineer role. I don't want to be a junior network admin anymore. I want that senior network admin role. I got my CCNA. I proved that I'm trying to improve myself and learn things outside my scope, outside of just our network here. So that may help you for your current role, right? Career improvement or raise for your current role. And this is just, a little screenshot here of the average salary. Now, if you guys have followed me for a while or Trepa Technologies, I'm a vet. I work in the DoD currently. I'm a senior network engineer. And a lot of times for the current students I have, my base, this isn't always true, right? Our average salary for our network admin positions in the DoD are going to be a little higher than the private sector for that specific role, right? Because we have clearances and stuff. So for anyone watching out there that is a vet or a DoD, you get your CCNA, you have your clearance, you might make a little bit more than this on average. I can only really speak for where I'm at Fort Bragg. I usually see people with CCNA get out and they make 80 to 100 grand on their first job. I've seen that a lot, but then again, they're leveraging clearance and experience they had in the military. But that's still a good average for a $300 cert, right? Especially with all the free training material out there. You can study damn near for free and pay $300 for a voucher, get it, and then you could be looking at a salary or career field in networking, making pretty good money. Okay, that was just certification. Now, let's start actually learning some stuff about networking. Alrighty, so what is networking? Let's define this word networking because it's going to be just, slam down your head, your throat, all week, the whole time we're training. So what is networking? So this is just a little definition I pulled off Google, to be honest. It's an all-encompassing term which refers to design, management, maintenance, operation of network infrastructure, software, and policies. Here's what networking is in my opinion, right? You have a client and they want to reach a destination. I want to go to facebook.com from my computer. Maybe I'm out camping and I bring my mobile Starlink, I put it on my backpack and I'm in the middle of the woods and I want to watch a YouTube video. From me to my destination, every component in between, all those hops that are not part of the web application or my web browser or my client, that is networking. My packet from source A needs to get to destination B, and that path that it takes to get there is networking. And your job as a network admin, engineer, your role is to make sure that my data, my packets, my whatever it is from my computer to my destination reaches and has a way back. That is networking. So all the infrastructure in between, all those hops, you manage it, you maintain it, you deploy it, you monitor it. It's your job to do all that. Install, maintain, manage, and troubleshoot the infrastructure that enables that data to traverse your enterprise and the globe and the internet. Now you may say, okay, wow, that sounds grandiose. That's awesome. So when I'm a network engineer, I make sure the internet stays on. Maybe, right? You go work at an internet service provider, maybe. But networking has a lot of different areas, right? And a lot of times the CCNA, a network admin, starts off in what I call networking in the enterprise, okay? Networking in the enterprise. So let's break that down. So most network professionals start their journey working in the enterprise. And this is what we call an intranet, where if you have a job, let's say you work at Discount Tire, right? You clock in, you go into work, maybe you clock in on a computer, your point of sale machine. And on there's a wallpaper that says Discount Tire, and you can access all the Discount Tire applications you need to do your job. Okay. But when you go home, how come you can't access that stuff? How come when you type in that internal website, portal.discounttire.com, you can't reach it at your house? Well, because that resource, that website, that resource, that web server is in your enterprise. that is on servers and on infrastructure in your enterprise. And a lot of times we start off our role in networking in that intranet, in that enterprise, where we're making sure just our company internal resources and clients can talk, okay? So I kind of draw it up here, networking in the enterprise, where maybe we work for discount, maybe we work for a bank, and we have our headquarters. And that's where all the corporate wigs are, HR is, and in there we maintain a data center. And in that data center, we have all of our internal company resources, where we fill out time cards, where we host a portal, where we host any unique application that we don't want sitting outside because it's just for our little businesses, right? Our discount tire offices. And we have a router here. And we have the switches here that make all this talk internally in our LAN. And we have our big router here. And this router we call our customer edge. Because at our demarc point here, we're going to talk to an ISP. And inside the internet service provider, how we get out to the internet, we don't control, right? We control just what's in our enterprise. And we have to make sure as network admins that all of our offices can reach our main office over here. And this could be in Arizona, this could be in California, and this could be in New York. And that is networking in the enterprise, where we build our own infrastructure to host our own network resources and that support our business operations, okay? So when I say enterprise, and when I talk about routing protocols that are typically interior gateway protocols within your own domain, that is talking about technologies and protocols that work within the enterprise, right? Okay, history. You know, when I made these slides, I had this big dreams like, oh yeah, maybe my company will teach 4-week boot camps one day. And we don't have time for this, right? I need to get you the exam objectives. So, finale here for this slide deck. As a CCNA, it is your job to ensure that the critical infrastructure that connects us stays online. You make sure that the internet stays on, right? So when you get your role as a network engineer, you have a very, very important role. You make sure that people's precious internet stays online and that they stay connected. Okay, now let's move on. Now we're gonna go over network components. I'm gonna take a brief pause here, real quick, guys. I'm gonna set up my whiteboard for this because I don't like to teach just from slides all the time. So let me, hold on. Where is my whiteboard here? There we go. Okay, so now guys, we're gonna go over network components. So this is gonna be that critical infrastructure that we just talked about that keeps us online. We're gonna go over each piece of hardware, each component that makes up the network, okay? What we call the network. Oh, my screen just died. Hold on one second. That's fun. That's nice. Hold on. I'm getting my whiteboard out over here. One second, guys. Okay, all right, we're there. Sorry. First day, you know, always got to get this stuff set up correctly. Alrighty, so we're going to be going over different network components. I'm going to start off by going over what a switch is. So the first network component we're going to talk about is a switch, which is layer 2. So we're going to go over a layer 2 switch. So that means out of the box, a switch is going to be layer 2, which means we're going to be forwarding based off MAC address. So I'm going to break this down for everyone. So here's what a switch is when we draw it on like a network diagram. You have these arrows here. And these switches are going to be forwarding based off MAC address. So what is a MAC address? So a MAC address, sometimes known as a burden address, is a 12 hexadecimal digit that sits on your network interface cards. Right now I'm on my MacBook. I have a Wi-Fi NIC, a network interface card, that connects to my wireless access point, sending Wi-Fi signals, and that NIC has a MAC address that uniquely identifies it on my network, okay? So MAC address is going to be 12, and this is a MAC. It's going to be 12 hex digits, hexadecimal is what it's called. And those hexadecimal digits are going to be 0 through 9 and A through F. So when I have a workstation over here, and I got my NIC, and I'm connecting off to my switch over here, that NIC is going to have 12 digits that make it unique, recognizable in my little switched environment, my LAN here, okay? So a MAC address could look like this. And then the next 6 digits are going to be something unique we're going to talk about. Okay, so that's what a MAC address looks like. So these first 6 digits here, that's going to be something called the vendor OUI. That means that if I'm on like a Dell Optiplex 7940 computer, and these all got manufactured in the same plant on the same month, every single desktop that comes out of that factory is going to have the same first 6 digits, okay? That's the vendor OUI. Then these last 6 are going to be unique, you know, the unique identifier. So this is what will be different, right, on those MAC addresses. Now, let's say this is PCA. So when I'm talking about PCA, I'm just going to use these last 2 because I don't want to keep writing out 12 digits, okay? So the whole point of a switch is to get our local area network here, it's called a LAN, talking, right? I set a switch forwards traffic based off MAC address. So how does it do it? So let's say I got PCA over here, and PCA wants to talk to PCB. PCB. And PCB's MAC address, just for brevity purposes, I'm not going to write 12 digits, is BB. All right. So how does this switch, let's say this is switch 1, get PCA and PCB to talk to each other? How does it forward or switch that traffic? Well, here's how it does it. When PCA wants to talk to PCB, it's going to create something called a layer 2 header. Layer 2 header. That layer 2 header is going to have a source MAC address itself and a destination MAC address. Okay, that source MAC address again is going to be itself. So that's going to be AF. And then it wants to talk to PCB. Let's say it knows it, okay? Just for these example purposes, it wants to talk to BB. So it's going to put in there BB. And then that layer 2 header is going to encapsulate its data payload, right? That data payload standard is like 1,500 bytes of information. This is the Teams message, the email, the whatever it is that it needs to send to PCB. So PCA has that. It's going to send this layer 2 message. We call this a frame, okay? We call this a frame when it's in layer 2. It's going to send that frame out to the switch. The switch is going to receive that on its interface. Let's say this is gig port 0/2. This is gig port 0/3. The switch is going to receive that frame, and it has what's called a MAC address table, otherwise known as a CAM table, content addressable memory. But I'm going to write this out. It has this MAC table, MAC address table, or it's called a CAM table. Okay, content addressable memory. They're synonymous. That MAC address table is going to be the brain of that switch. It's going to tell that switch how to forward traffic. So when it receives that frame, that ingress traffic, it's going to take that source MAC address and it's going to insert it into the MAC address table. So it's going to say, hey, hanging off gig 0. So let me backtrack. I have a port here. I have the MAC address for it and whatever VLAN it is. Jumping ahead a little bit, but that's what you'll see when you do the command show MAC address table on a Cisco switch. You'll see what VLAN it's a part of. Jumping ahead, I'm not going to teach that right now. So it's going to take that ingress traffic, that source MAC address, and insert it into the MAC address table. It's going to say, hey, off gig 02, I have MAC address AF, okay? So that's how it learns to forward. And previously, if PCB has sent traffic, what's it going to have in its MAC address table? It's also going to do the same thing. It will receive PCB's traffic, look at the ingress, look at that source MAC address and say, oh, okay, yeah. MAC address BB lives on gig 03. So now, PCA send that frame, right? It takes the source MAC address, inserts it into the MAC address table, and then it's going to look at the destination. It's going to look at the destination and say, hey, do I know where to send this? Well, let me reference my MAC address table. Okay, MAC address BB is on gig 03. So I'm going to switch that traffic out gig 03. That's how switching works when you know where the destination MAC address is. It's that simple. We have a MAC address table that's populated, and when we receive a frame, we insert the source MAC address if it's not already in the MAC address table, and then we look at the destination MAC. We say, okay, we're trying to reach here. Let me reference my populated MAC address table if it's populated, and if there's an entry for that MAC address table, I know what port to switch it out of. Simple as that. Now, where does it get complicated? And where may they ask you this on the exam? What if, same scenario, but PCB has never talked to the switch? What if PCB has never talked to the switch? So the switch is going to receive that frame. It's going to look and say, you're trying to reach destination BB, but I just referenced my MAC address table, and I have no idea where it is. Well, what are we going to do then? Well, we're going to do something called frame flooding. If there is an unknown destination MAC address, we're going to do something called frame flooding. And what frame flooding does is it's going to convert that destination MAC address field into all Fs. So we're going to create a new layer 2 header. We still have our source MAC, and then it's going to be the destination all Fs. And we're going to flood that broadcast MAC address is what we call it. So we're doing frame flooding for an unknown destination MAC address. We have all Fs, right? That's what's going to be our broadcast MAC address and our broadcast frame. And we're going to flood that out every active interface besides the one it came in on, okay? And once we do that, all the active interfaces respond. And when PCB responds to that flood, responds to that broadcast message, that broadcast MAC, then what's going to happen? It responds. The switch receives that response and says, oh, cool. MAC address BB, yeah, you're off gig 03. Okay, yeah, I got you now. I got that entry. That's how we forward what a switch does when there's an unknown destination MAC address. So I'm going to type that out for you guys. So, unknown destination MAC. What are we going to do? We're going to do something called frame flooding. This is when we send out a broadcast MAC address message to all active interfaces besides the one the request came in on. So if we receive a frame on our switch for an unknown destination MAC address, we're going to do something called frame flooding, okay? And we're going to send out a broadcast MAC address message to all active interfaces besides the one it came in on, all right? Very important there, active interfaces. So if this is like a 24-port switch, but only gig 03 and gig 02 are connected and active, right? That frame's only going out what port? Only gig 03, right? So very important that we know that. Okay, that is what a switch is. So just to recap, a switch, it forwards based off MAC address. It has a MAC address table where it puts entries in for those MAC addresses based off the ingress source MAC address. And out of the box, it's layer 2. However, little caveat here, guys, just for your knowledge, it can be layer 3, okay? It can be what we call a multi-layer switch. So that is one of our major network infrastructure components. And typically a switch sits on what we call the LAN, right? And it switches for our local area network. Okay, moving on. Now, we're going to talk about routers. Now we're going to talk about routers. Another critical piece of infrastructure in our network components section. So what is a router? Well, a router, again, is going to, well, not again, but we're going to go over what layer it sits at, right? A router is layer 3. A router is going to forward based off IP addresses. That's going to be IPv4 or IPv6. In this example, I'm going to go off IPv4, right? Just a little simpler. So, one second, let me get back to this other screen here where I got my notes. All right, so routers are layer 3, and their whole goal, router's whole goal is to forward IP-based traffic. We call this packets, okay? We call this packets. So let me draw this up here. Let's say we have R1, and R1 is connected to R2 over here, okay? And let's say this is serial interface 00. And this layer 3 connection here has this IP address. So we have .0 over here, .1. R1 and R2 are both going to have local area networks. So they're both going to have users sitting on their LAN side, okay? So they're going to have, let's say our R2 has 10.2.0.0/24. R1 has 10.1.0.0/24, okay? If I want my users over here, let's say I have a PC over here, PC1, and PC1 is .5, and I have another PC over here, and this is PC2, and this is .5 on this network, right? Two different networks, and they want to talk to each other. What is going to happen? These routers are going to have to forward IP-based traffic, because now we're getting outside of our LAN, we now get into IP addresses, and IP addresses are a unique identifier that our devices have for network connectivity on the internet and in our enterprises, okay? So let's run down what happens here. So when PC1 wants to talk to PC2 over here, PC1 lives on R1's LAN, PC2 lives on R2's LAN. PC1 is going to create, you guessed it, another header here. It's going to create a layer 3 header. Okay? We're going to have a source IP, and we're going to have a destination IP here. So the source IP will be .5, so it'll be 10.1.0.5. And its destination is 10.2.0.5. And then, of course, we always have our data payload, which is 1500 bytes standard, okay? We call this also the MTU. More on that later, maximum transmission unit. So when the PC sends this off, it's going to send it off to what's called the default gateway. The default gateway is going to be the interface here off the router, typically, and that's going to be what's receiving this packet, okay? We call it packets when it's layer 3. So we send that packet off, and the router is going to inspect it. It's going to say, okay, I see the source IP. You're connected to my local connections, my connected sources, and I see you're trying to talk to 10.2.0.5, an IP address outside of our subnet here, outside of our network. So I need to route you somewhere. Well, what's the brain of that router? This router is going to have something called the global routing table. It's going to have the global routing table. Let me write this up here. Global routing table. Also known as a RIB as well, router information base, okay? Synonymous. That global routing table, just kind of like very similar to our MAC address table, is going to have entries in there that tells that router how to forward for destination traffic, for the traffic it's receiving from its users. So an example of this. This global routing table is going to have its directly connected links on there. So it's going to have a connected link for 10.0.00/30. That's going to be via serial 00. Okay? It's also going to know about this directly connected link. Let's say this is gig 00 here, right? It's also going to have a connected interface here. That little C right there is for connected. It's like router codes, okay? It's going to be like, okay, I also have connected to me 10.1.0.0/24, and that's via gig 00, okay? Now, we have our user trying to reach 10.2.0.5. That's outside of our network. So now the question is, how does R1 learn about R2's LAN over here? And vice versa, because we need a way back, how does R2 learn about R1's network. Well, these routers are going to share what they know about with their neighbors. They're going to share prefixes, that's synonymous for like subnets, for networks, with their neighbors. We enable this with something called a routing protocol. So we have to configure a routing protocol so that these two routers can talk to each other, say hello, become neighbors, and then start exchanging routing information with each other. Really just prefixes and networks with each other. So now we have to configure a routing protocol like OSPF. And when we configure OSPF, R1 and R2, without getting into the major details, because we have a whole section on OSPF, is going to say, hey, R1, I got the 10.2 network over here. R1's going to say R2, hey, R2, I got the 10.1 network over here. And once they receive those routing updates via the routing protocol we configured, they're going to insert that routing update, you guessed it, into the global routing table. So now in my global routing table, I'm going to have an entry for the, remember this is R1, right? For the 10.2 network. This code is an O for OSPF. I learned it via that routing protocol. And when I want to reach that, I have to go out serial interface 00. So this global routing table is my brain. That's the whole brain of this router. That's going to be what needs to be populated, what needs to be filled out via routing updates and messages from the neighbors so that we know how to forward traffic, okay? So that is routers. Now, guys, I don't know, I keep coughing and choking. I need to go grab some water. I don't know if it's like dusty in here or something. So I'm going to go on another 10-minute break. I'll come back at like 6:18. Yeah, I'll come back at 6:18. And then I'll put a timer up here so when we return, and then I'll come back, strong. Okay, yeah, for my live viewers, sorry, I know it's a live stream, so it's like weird to take breaks, but I'm teaching a Zoom class with like real students. So, I don't like to teach like I don't want to kill them with constant just droning on and lecturing. So, they paid money for this, so I want to make sure it looks good for them. But okay, awesome. I'll come back in 10 minutes. Okay, let's go ahead and get back into it, guys. So we just went over routers. Now we're gonna go over our next infrastructure component, and that is gonna be firewalls. So let's take a look at firewalls. So this is another critical network infrastructure component. And typically a firewall, when you're looking at it just on the network, right? In a traditional networking sense, you're not a firewall in the cloud, not like an NFV anywhere else. It sits in line, right? And it's typically actually might be your demarc point. It may even do routing for you, VPN concentration, IDS, IPS. But the basics of a firewall is to just protect and filter incoming and outgoing traffic to and from your enterprise, whatever your network is. So typically how we like to look at a firewall in a traditional sense, when we look at it, we have a firewall right here in the middle. So our firewall. Then this firewall is going to be connected to the internet. So that'll be connected to our ISP, internet, whatever that may be. And then it'll also have a connection to probably like maybe a router, or maybe that's the dedicated routing appliance. And again, the firewall can be doing the routing too, but we're in the CCNA, so we're gonna go on how the CCNA wants us to look at a firewall that is just there to do security, filtering inbound and outbound traffic. And then you may have like, you know, that switch and then all your resources here, okay? So what we call this in firewall technologies and in network security is a zone. A firewall zones out its interfaces. So this zone is typically going to be called the inside zone. Inside/trusted zone, okay? And you'll have like a security level on this. Typically, you know, it depends who you ask. There is like Cisco documentation and white papers, but this zone will be connected to this interface, whatever it may be, and we'll give that interface a name. Then that name will be in the zone, and we're going to have a security level on that zone. Something like a level 100, which means like safe, secure. We call that the inside or trusted zone. And then we're connected off to our untrusted zone, or our outside zone. So we'll call this untrusted/outside zone. And this will be like a level 0, meaning like, hey, we don't trust it at all. And that's typically where most of our heavy duty filtering is going to be. That's where we're going to have what's called access control. Well, we're going to have them here as well, right? It just depends how we set up. But our firewall is going to have what's called ACLs, access control list. And in those access control lists, we're going to have access control entries. And we're going to apply those ACLs inbound and outbound on our interfaces and these different zones, okay? So we also may have something like this too, guys. Something called like a DMZ, or a screened subnet is now what CompTIA calls it, but a DMZ zone. And this will be like a level like 25 or like 50. And this is maybe where we put architecture that talks inside and outside, right? To the internet and to our internal users, okay? So that's what a firewall does. If you're getting ready for the CCNA exam, a firewall filters inbound and outbound traffic. How it does that again is with something called ACLs, access control lists, which have access control entries that permit and deny. So let's break that down. So based on our firewall, how are we filtering? So we have our standard traditional firewalls that are going to filter via layer 3 and layer 4 traffic. So a traditional firewall, let me make this in black, is going to be filtering via layer 3/layer 4. So we're going to be permitting and denying via layer 3 or layer 4, meaning I'm permitting this IP address in, or I'm permitting this IP address when it equals port 443 HTTPS into this server here, okay? So that's just our traditional firewalls. And then we have our next generation firewalls. These go a step further. Our next generation firewalls are going to be able to do things like TLS inspection, de-inspection, and actually be able to filter based on content, not just based off an IP address or a port number or protocol at layer 4, like TCP port 22 we're permitting, and we're denying TCP port 23. This goes a step further. A next generation firewall actually can do what's called whoa, I don't know what just happened. I clicked a button, sorry. It's actually going to be able to do what's called DPI, deep packet inspection. And this is where we can do content filtering and URL filtering. But this is also, for the next generation firewall, where we add in AI/ML. Now, of course, when I say AI, when I'm doing AI, right? Or when I say AI, all of a sudden we're like, oh, hey, AI is ChatGPT and that's it. Or these AI companies that are just wrapping REST, API calls in ChatGPT, just using GPT and calling themselves an AI startup. Now, when we look at AI and ML in like a firewall, next generation firewall for the CCNA exam, a big thing we're going to talk about here is something called user behavior analysis. Well, we're going to enable a large learning model, machine learning, to create an AI agent on that firewall to do analysis on our baseline behavior. So if we're doing UBA, user baseline analysis, and we notice that users are always going to, YouTube, Facebook, and our portals from 9 to 5. That's where our heavy duty traffic is. So we enable this ML, machine learning, this AI agent on our firewall to inspect that traffic and say, this is what's normal, right? This is our typical behavior baseline. That's our analysis, that we're going to these websites from 9 to 5, okay? So we do that for about a month. And then once we have that analysis, we create playbooks that say, if you notice network traffic or behavior that deviates from this baseline, here's how I want you to react, okay? So then when, let's say at 2 a.m., all of a sudden we have a user over here with destination traffic to port like, what's like a bot port, a well-known bot port. I'm not teaching cybersecurity right now, so I don't know. It doesn't matter. It has TCP destination traffic to something malicious, right? Whatever that is. Okay, there's well-known port numbers and IP addresses that are like blacklisted and they're well-known, right? Even like DNS tunneling. Anyways, and we see that spike. And we see one gigabit of traffic trying to leave at 2 a.m. Our AI agent, based off the information that our large learning model, machine learning created, and based off the playbook we told it to, can go and stop that traffic, right? That's what AI does when it comes to security, now on our inline network devices, okay? So what kind of firewall does all this stuff, guys? We call that a next generation firewall, okay? Very important for the CCNA exam. Okay, guys, now let's go over Wi-Fi. So we're gonna go over access points, okay? So another critical infrastructure is gonna be access points and a wireless LAN controller. So there's gonna be 3 different types of access points we're gonna talk about. So we're going to, and this is part of our Wi-Fi section of network components, right? So we're gonna have an autonomous access point. We're gonna have lightweight access points. And we're going to have cloud-based access points, okay? Cloud-based access points. So we're about to define all 3 of these, okay? So an autonomous access point, we're talking access point, we're talking Wi-Fi and wireless now, okay? So an autonomous access point is exactly how it sounds. A single piece of hardware infrastructure that connects to a broadband connection, ISP, and it's going to provide all the routing, the switching, the firewall services for you, and of course that Wi-Fi signal for our Wi-Fi enabled devices to connect to. So an autonomous access point, and yes, I work in tech, guys. You know, I'm not very artistic, so excuse me if some of these imagery is bad, right? In this autonomous access point, this thing is going to be doing the routing. It's going to be doing the switching. It's going to be a firewall for us. It's also going to be like a DHCP and DNS server, handing out IPs and doing host name to URL resolution, what DNS does. It can do everything for us. And it's also going to be emitting that Wi-Fi signal on a 2.4 gigahertz or 5 gigahertz or 6 gigahertz channel, depending on what level of Wi-Fi, for all of our Wi-Fi enabled devices to connect to. So it does it all. So when I'm configuring this autonomous access point, so here I am configuring, I do this from a single web GUI, right? I access this autonomous access point, I do everything from there. All that is internal on one device. So an autonomous access point does it all for us. It's going to connect off to an ISP.
And typically these autonomous access points are going to be for our SOHO environments. That's our small office, home office environments, okay? So this is supporting 1 to 20, it's not a lot of users. You don't want to put a lot of users on an autonomous access point because it does not scale, right? This is just for our small offices, home offices where there's not a lot of, infrastructure there to begin with. And maybe all your enterprise resources for small businesses in the cloud are using G Suite, Google Drive, paid for cloud-based SaaS services, right? So that's an autonomous access point. And of course, it'll be emitting an SSID as well. And that SSID correlates to that, network, that wireless local area network. So that's autonomous access point. Now let's get into lightweight. I'm gonna try to do a little deep dive on lightweight. And I say deep dive, I mean, just enough for the CCNA to make you dangerous, right? And once I describe lightweight, learning cloud-based is going to be easy because the access points themselves, the actual device emitting the Wi-Fi signal, lightweight and cloud-based, they're the same in that they need another server or controller to get their configuration. So let's go over this. I'm going to need some space here, okay? So lightweight access points need what's called a wireless LAN controller to get its configuration and to, route and route traffic for our Wi-Fi enabled devices, okay? So a lightweight access point is controlled by WLC. That wireless LAN controller, think of it almost like a server, I guess, that has a single pane of glass for managing, configuring, and deploying hundreds or thousands of lightweight access points across your big enterprises. So the lightweight access point is for thousands of users, right? Think of when you go to the airport, you go to a football game, you go to your day job, and maybe you have 24-story office building, and if you're working on the first floor or the 24th floor, you're connected to your same, accounting SSID on all those floors, right? That is a big enterprise with a huge wireless infrastructure. And if you're managing that all on-prem, meaning that wireless LAN controller sits in your data center, or maybe sits at your hub's data center, it's on-prem, it's in the enterprise, not in a cloud-based service, you're using lightweight access points. So let's break this down. I'm going to draw out like a campus network here. So we have our multi-layer switches, okay? And then we have our access switches. Now this, I'm not going to draw the full 3-tier core topology. This is just something simple, right? So these are our distro or core switches, right? Maybe we have a collapsed core topology, okay? So here's our layer 3 switches. Here's our layer 2 switches. So at the access switches, we call this the access layer as well, we're going to have all of our lightweight access points. I'm going to put X10 here, right? And then we have another access point here. I'm going to say X20. So 20 access points, okay, in our environment. Now, again, remember, these access layer switches, maybe we have 30 of them all throughout our campus network, right? We have a big compound, okay? So all these lightweight access points, they need to route traffic, take traffic for 3 different networks. So let's break this down. Let's say we have a sales department. Let's say we have an accounting team. And let's say we have marketing. I'm going to just put Mark there. Mark. Mark for marketing, right? So on our sales network, let's say that's VLAN 10. And that is the IP address 1.1.0/24. And then we have accounting. That's VLAN 20. And that is 1.1.2.0/24. And then we have Mark for marketing. That's really our marketing VLAN, right? And that's VLAN 30. And that's 1.1.3.0/24. These are all VLANs that are on our switches. And if we connect a computer to this access layer via like a Cat5 and Ethernet cable, they'll be assigned that VLAN. They'll be part of that network. And now we need to extend that to our wireless infrastructure. So here's how we do it. We deploy all these access points. We do a heat map, a wireless survey to see how we're going to get the actual RF signal, the Wi-Fi signal, good coverage, right? And then we're going to have, what color should I make this? A WLC, okay? This is kind of what a WLC looks like in like Cisco imagery. A wireless LAN controller. That wireless LAN controller, you're going to build in there wireless local area networks. You're going to build wireless local area networks that correlate to your networks that live on your physical infrastructure, right? Your distributed network is what we call it. So you're going to build a wireless local area network for the sales VLAN 10, and in there you're going to pick what type of security, WPA 2/3. You're going to pick the radio types, and what that means is, what frequency are we on? Are we going to be doing 2.4/5 gigahertz? Are we going to be doing 802.11 AX or AC or G? You're setting up all the wireless configuration, right? Are we going to be doing WPA2 PSK/enterprise? And then also you'll need your subnets, right? Your actual network address and things like that, right? So you're going to set up, if we have 3 VLANs, 3 wireless local area networks. And each wireless local area network is going to be represented by something called an SSID, a service set identifier, right? A service set identifier. That service set identifier is then going to be broadcasted on a Wi-Fi signal in a certain frequency range for our Wi-Fi enabled devices to connect to. So once we built all those wireless local area networks, we're going to push that configuration down to our lightweight access points. Now, before all this, our lightweight access points are going to go through a connection state, right? Where they have to get connected to, they're going to get connected to the wireless local controller, right? Anyways, and we don't need to understand that process. We can do it via DHCP. You can statically set those access points to connect to that wireless LAN controller. But either way, we're going to push down that configuration, okay? And when we do, we have 3 wireless local area networks. Each one of those lightweight access points could potentially, let me color coordinate here, be broadcasting for the sales VLAN. So we'll have SSID sales, right? And again, that correlates to the wireless local area network we built over here on our wireless LAN controller. That correlates to this network over here. We could be broadcasting an SSID for accounting as well. So SSID accounting. And I think you get the picture here, right? So there we go, right? That's lightweight access points. So you may be saying, okay, cool, I get it that this wireless LAN controller does all this. We configure all this stuff here, and it pushes the configuration down to these access points. We could have 100 access points, right? It's going to push that configuration down. But how? How does it do that? Well, like I said, there's going to be a peering session, right, where these lightweight access points are going to connect to that wireless LAN controller, right? And that connection, they're going to build something called CAPWAP tunnels. Yes, that's a real word. They're going to build CAPWAP tunnels. They're going to build 2 CAPWAP tunnels. So every lightweight access point is going to build, oh, I wanted that to be purple. Hold on. Every lightweight access point is going to build a control CAPWAP tunnel, a control tunnel, and you guessed it, that control tunnel is going to be how it gets all that configuration and that profile pushed down to that access point. So from wireless LAN controller to lightweight access point, we're going to have a CAPWAP control tunnel that's pushing down that configuration, right? And then we're also going to have a data tunnel, a data CAPWAP tunnel. And guess what that data is? If it's configured standard, right, because there's going to be something called Flex Connect that we'll get to. If I have 2 users in the accounting SSID and the accounting VLAN connecting to the same SSID off that same lightweight access point, and they want to talk to each other in a typical deployment without any special configuration, because there are things like Flex Connect that we can configure where this doesn't happen, but all traffic from our users is going to go through that data tunnel to the wireless LAN controller, and then the wireless LAN controller is going to decide how to route that traffic, okay? Whether that means going out to the internet or all the way back down to that same access point to talk to the user over here that's connected on the same SSID to the same access point. Whew, that's lightweight, okay, guys? Whew, try to make that as simple. I'm not sweating, I swear. Try to break that down as simple as possible. Now, big picture, right? Let's look at this from the holistic view again. Lightweight access points. They're there for large enterprises. That wireless LAN controller sits on-prem, but it can control access points that are in spokes, that are geographically not co-located to that wireless LAN controller, right? Like this HQ could be in Phoenix, Arizona, but we could have a spoke office in Washington, little router, switch, access point, And we do have the capability, if we configure it this way, to have this access point talk to this wireless LAN controller over here in the HQ, right? Now, obviously, there's ISP in between these guys, and we're going to set up some routing and stuff, GRE tunnel stuff that we're not going to go over right now, right? But that's possible. That's lightweight access points. You do all the configuration from the wireless LAN controller. Now, back over here, we have cloud-based as well. So imagine all this that I just talked about, lightweight access points. And when it's cloud-based, instead of having the wireless LAN controller on-prem, you're connected to like the Cisco Meraki cloud, and you're sitting over here at like Starbucks, right? From your admin laptop, you connect to the Meraki cloud, you get to that Meraki cloud dashboard, and there you configure everything. And our access points are connected to this Meraki cloud. That's the difference. That's it, right? Now, instead of a wireless LAN controller hosting its own web GUI that you have to connect to this IP address here, you connect to the cloud, and the cloud is going to manage and configure all those lightweight access points. That's the only difference. Okay. All right, guys. So take a little breath here. Now I'm going to go over controller-based networking, and I will go back to the slides for this because it's hard for me to draw this out as well, okay? Okay, so now let's go over controller-based networking. So what is an SDN controller? What is software-defined networking? What is controller-based networking? So I made these slides 4 years ago. I probably need to update because in here I have a relatively new concept. It's not relatively new at all. It's damn near the standard for a lot of our WAN connections. SD Access or Catalyst Center in Cisco is like damn near the standard for all large enterprises now. It's just a way to control and configure our devices, not the traditional way we would. So traditionally, how do we configure like a switch or a router, okay? So traditionally, we configure a switch, a router, a firewall by consoling into it from our admin computer or initiating an SSH session on PuTTY, right? And what do? We go into the CLI, we send a bunch of CLI commands, and we configure those devices. Something that you're about to do because the CCNA exam has all those labs, right? So back in my EVE-NG session here, hold on, guys. Did I stop sharing? Hold on. I need to share my screen. My bad. I'm just talking. And I need to be sharing. Okay. Sorry about that. Here's the slides, right? So it's a relatively new concept where you can provision, manage, and control traffic from a centralized point. Okay. So now, back in EVE-NG. So let's say these are real switches. I would console into them. Okay. Hold on, I'm opening up Secure CRT. 1 second. Hold on, let me do HTML5. Eve. And if I want to configure this switch, I would come here, enable, go to global config, give it a host name, and call it switch 1. And everything I do when I configure, let's say, it's a switch, but VLAN's on this switch. I configure a port channel. I configure spanning tree. I configure CDP, LLDP, any layer 2 technology I do from the CLI. And if I had 30 switches in my environment in a traditional network, I'd go to each 30 of these switches, SSHing to them, consoling to them, and running these commands. Well, with SDN, controller-based networking, it's a whole different approach to configuration. Or instead of doing it individually on a command line interface, we have a single pane of glass web GUI that is connected to all these devices. And through a GUI, through some buttons, I can send configuration, routing policy, security configuration down to all my devices at once from a centralized point. So if we look at this here, controller-based networking, it's called Catalyst Center now. I do need to update some of these slides. I've been getting away with this for a while now, but it's Catalyst Center, right? It's been like that almost a year now. You can see we have our Cisco Catalyst Center here. It's a single server that we have a web GUI connection to, HTTPS connection, and that server is connected to our fabric down here. We call this software-defined access in Cisco. And we have all these switches, routers, firewalls, even access points, right? Even access points. And we configure policy all from this centralized place. We can automate iOS upgrades from here. We can get telemetry, do compliance, all from this one centralized place that's going to push down that configuration down to our switches and our fabric under here. We call that centralizing the control plane, okay? So we're gonna go over that, but there's planes on our devices called the control plane, data plane, management plane. The control plane is all the technologies and protocols you configure on your device to give it its logic. Like in a router, the routing protocols are control plane technologies that logically tell that router how to, route traffic, how to put things in the global routing table. And with controller-based networking, we take away that control plane from the individual device and centralize it into a single server like Catalyst or DNA Center. And then we configure that centralized server, and that server has like a southbound interface, what we call it, that connects to the fabric, hundreds of switches, routers, firewalls, access points, and does the configuration, okay? That is controller-based networking. So the platforms you gotta know about kind of for like the CCNA are Cisco Catalyst Center, SD Access, which is not really a platform, it's more just like that's what it is when we're doing Catalyst Center for our LANs, right, for like our campuses. And then of course SD-WAN, that is a software-defined WAN. That gives us the ability to do like transport agnostic routing over multiple ISPs and quality of service, all from, again, a centralized place, okay? And then we're gonna end it something simple. So like I said, day one, right? It's like drinking from a fire hose. We're going over all these network components and infrastructure. An endpoint. This is any device or any system that users in the enterprise use to access resources. So what does that mean? Printers, VTC machines, servers. Servers are an endpoint. Computers, laptops, anything that's not part of that network infrastructure that gets you from point A to point B, that's not passing that traffic throughout the internet or the network, that's an endpoint, okay? Pretty much what you're on as a client, right? What your client's getting on every day, that's an endpoint, all right? Okay, cool. So now let's go ahead and move on to our next section here. So now we're gonna go over hardware components. I'm gonna go over these hardware components and then we're gonna take another break. So hardware components, what I'm gonna talk about is like, kind of like A+ for networking. And what I mean by that is, what are the components that actually make up a router or a switch, right? Like, is there a motherboard? Is there RAM? Is there CPU? Spoiler alert, there is. It's just a computer, but a purpose-built computer, if you really think about it, okay? So I'm gonna go over the hardware components of a Cisco router and switch. So what's in a router? Okay, I'm gonna start with the router. A switch is very similar, except all of its interfaces are gonna have like something called ASIC chips, which are purpose-built to do switching, right? It's like CPU, it's the same kind of compute as CPU, but it's doing one thing, and that's just switching traffic, where a CPU can do multiple different things. And just to show you here, right, I have my switch. Actually, let me expand. Okay, you can see like a 48 port switch here. If I open this switch up, there would be a motherboard in here. For my Zoom guys, hold on. Let me start my video. So I don't know if y'all can see that on the Zoom, but yeah. There's a motherboard in here. There's gonna be CPU, there's gonna be RAM, there's gonna be ROM, and every single port here on a switch is gonna have something called an ASIC chip. So again, not like a computer where I got like GPU in here and like I need it to do gaming. It's purpose built, but cool. Just wanted to show off my 48 port 9300 Catalyst switch there for a little bit. Okay, so what's in a router? So a router is gonna have all the similar components that a computer would have. It's gonna have CPU that executes the operating system instructions just like computers. It's gonna have something a little bit different called ROM, read-only memory, which holds diagnostic software used when the router is powered up. It stores the router's bootstrap program. That bootstrap program is what pretty much gets our iOS, right, and runs our operating system. This is the BIOS. So when you get a new computer, you gotta image it, you go to the BIOS settings and you image it over the LAN or over USB or whatever, or the UEFI settings, BIOS settings. That's called read-only memory in a router. We can actually get into ROM on mode if we ever have a corrupted flash or need to do something before corrupted iOS, in the flash, before our operating system loads. And then we have something called RAM, same thing. So random access memory stores the running configuration and other like caches, so like the ARP table, the MAC address table, the routing table, stuff that's in real-time runtime environments, that's gonna be operating on the RAM. And then we have something called the NVRAM. This is actually a file that stores your running config and puts it on the flash. So what is the flash? So unlike computers, routers and switches have something called flash storage. So it doesn't have a hard drive or a solid state drive, it has something called flash. And that flash is gonna be where your iOS is stored, just like the C drive is your SSD and stores your Windows operating system on a computer. The flash is your storage that holds the Cisco operating system, okay? And then it's also gonna have extra files in there like the startup config, which is like when it boots, we load that startup config into the running config into our runtime environment. So any configuration we saved in that startup config, we call that startup config NVRAM, non-volatile RAM. Because RAM, right, is only accessible in a runtime environment. So if I reboot my switch, I have to rebuild that routing table and that ARP table again, all those cache tables, okay? Okay, so what's the boot process for a router or switch? So first we boot that thing up, it's gonna do its post check. So this is gonna check the inputs and outputs of the hardware, much like a BIOS check or a UEFI in a computer. It's gonna make sure the inputs and outputs are good. And then it's gonna load us into read-only memory. And from there, we're gonna load the bootstrap program. That bootstrap program is gonna be the thing that allows us to get an operating system to boot into. So we're gonna search for an operating system, either on the flash or via the network, via TFTP, much like when you image a computer and you do pre-execution environment, PXE, it's gonna look on the network. If there is no good flash, we're gonna stay in ROM-on mode, in the ROM, okay? Excuse me, if there's no good operating system in the flash, we can't find one on the network, we're gonna stay in ROM-on mode. If we do find a good operating system, we're gonna boot that iOS, that operating system, and we're also gonna see if there's NVRAM. If there is NVRAM in a typical startup, we're gonna grab that NVRAM startup config file and boot us into RAM, the running config with that file. So really it's I simplified it here. Post check, read-only memory, look in the flash for iOS. If there's NVRAM, we're gonna grab that and boot us in to our running config, and then we're in our runtime environment for our routers and our switches. Okay, simple for our hardware components. I'm gonna spend too much more time on this. Again, my throat is like, I need to take a break, get some water, guys. So I'll put a timer up. We'll come back in 10 minutes, and then hopefully in the next hour, we'll finish up everything else. For the people on YouTube live stream, I'm gonna go ahead and cut it off. I just like to give like a good hour and a half, 2 hours, and then from my paying customers, I'm gonna finish the lessons. If you're ever interested in coming to this virtual training, check out our website. So thank you all on YouTube for viewing. I'll repost this video as well, so it'll be on the channel. All right.